Hello, I hope everyone is having a great day when they start watching this video. Today we're going to start learning about circuits. So as always, I like to do we're going to do some review and then we're going to dig into our questions. So first thing is, what is electricity? So this is something we talked about about a week ago now. Electricity is our flow of electrons through our material. When we talked about voltage, we said voltage is the amount of electrical potential, that our current is the rate at which electrons flow, that our resistance is resists the flow of the current. So our voltage is this guy right here trying to push through our current. Our current's trying to get through this little gap, but our resistance is making it a lot harder to get through. We used water to think about these things. So our volt to be our water pressure, how much water is getting put out. A resistance could be like us putting our thumb or something like a finger over the end of a hose in our water, and then the amount of water coming out being our current. So that is just a quick little review. Our questions to get us thinking about circuits is, how does a flashlight work? So take a second, maybe pause the video. But how does a flashlight work? And then also, how does a light switch work? So kind of the same idea. These are both circuits based, and we're going to learn about how a switch can either close or open a circuit and what that looks like and what that means. All right, but our objectives today are understanding the basic parts of a circuit and then be able to draw some circuit diagrams given some real life situations. So here's a quick video. As always, it's going to be linked in our Google Classroom, so please pause this video and go watch this one. It does a good job of introducing the topic for today. But what we're going to be talking about is the basics of circuits. So a circuit is used in anything that is electrical or has electricity, can be simplified down to these nice diagrams. So it looks like my camera's even cutting this off a little bit. I'm sorry about that. But we have our pictures. Here's a light, a switch, and a battery. So we have this battery gets replaced with this symbol. Our light gets replaced with this symbol, and our switch, which you can't see, we'll see another one, gets replaced by that. These circuit diagrams are super important for planning and designing new circuits and even understanding old ones as well. By being able to put it on paper and simply draw it out, we can analyze the system, change it, and make it better. So we're going to say our first definition about a circuit diagram, our electrons flow, or the first thing we're going to learn about circuit diagrams is that electrons flow from the negative side in the battery to the positive side. So we're always going from negative all the way around this way to positive. And flow only happens when our circuit is complete. We'll talk about what that means in just a little bit. Here's a little bit bigger picture of this. What we mean by complete is that right now we have this switch. This switch is open. It's like when our lights are off in our house. And when we turn the light on, this switch will move. This part of the switch moves to connect to this black circle. And now our circuit is complete because we have no breaks or no holes in it. Our electrons are going from this negative side of the battery all the way around to our switch, down and around until they reach the positive. So a big part of this is how each physical part gets changed into being a symbol. So we already saw a battery, a switch, and wire, but each word has a symbol. Some of the basic ones we're going to talk about today are wires, batteries, a switch, a bell, and a motor. So this is what a bell looks like. A motor looks like this. We have a switch right here, batteries, a lamp or a light globe is really like any kind of light, and then just any line is kind of our wires. A few of the other ones we see up here is a resistor, which a resistor is an electrical part with a set resistance. And they're used to protect other very important parts. So the idea we saw in our review picture is that a resistor only allows so much current to go through it. And so sometimes, maybe for whatever reason, there might be more current coming from our power station or even in our house, and that resistor slows down our current to protect the really expensive parts. We have an ammeter, which has an A in it, just a circle with an A, which is a device to measure the current in a circuit, and a voltmeter, which is a device to measure the voltage in a circuit. So these are just some measuring devices. When we see meter, it helps us measure. So let's look at a simulation. We're going to look at our simple circuit. We're going to put a light, a battery, and a switch in there. And then we're going to try different replacements with the light and see what happens. We're also going to try to measure the volts and the amps. And then we'll try a little bit more complicated and yet even more complicated and see what happens. So if I click on our simulation, we go to this PhET Interactive Simulations. We've seen this before. I think it does a really good job of showing us what we're doing. All right, so we're going to put our wire. We're going to put a battery. Oh, there we go. And a light bulb. What else? Do we put a switch in the first one? Light, battery, switch. We're also going to put a switch. So we're going to try to recreate what we saw in our first picture. So I can connect them by putting these two little circles together. I can put that circle there, and this wire is there. All right, so it doesn't look great, but they're connected. But right now our switch is open, and our circuit, we can not see anything moving. We can't see our electrons going through. By clicking on this, it closes the circuit, and we can see the electrons flowing through and making our light bright. So the cool thing about this is we can pull different things, different ideas. We have wires, a dollar bill, a paper clip, a coin. We could also put in more wires, a dog, a hand, to see what would allow electricity to go through it. We also can see it in our diagram form. So we can see what our wires would look like just normal. We have our battery, which looks like this. And then we have a light, which looks like this symbol. We could also come over here and pull out I accidentally pulled out two. I don't know how that happened. We're only going to use one of them. And this is a current, ammeter. We can measure our current and see how much current's going through. We also have a voltmeter, so we can measure how much voltage. So we have lots of cool tools in this example. For our voltage, we have to put a red and a black on either side of our battery, and for our ammeter, we just put it over any part of our circuit. But let's see how these numbers change as I open it. So our voltage stays the same. We still have the same amount of electrical potential, but now we have zero current because we don't have any flow. Again, going back to our water analogy, we wouldn't have any water going through our system unless it's closed and complete circuit. So we have that. All right, what's the next thing we said? We're going to try to replace it with different things. So let's replace our light with something else. So let's replace our light with a pencil, just for fun. I'm going to put another wire in just to make this easier for me. So what happens now? We have a pencil that is allowing current to go through, but our current is smaller. We were at 0.9 and now we're at 0.36. And that's because a pencil is made of carbon, which is a conductor, but it's not a very good conductor. Our light bulb is much better. So we don't have as good of a conductor. So we can take this out. Let's try one more just for fun. Let's see if a dog would work. And we see we don't have any current. Our current is closed. No matter if I open or close our switch, we're still going to have zero current because a dog does not conduct electricity. Let's do one more. Paperclip would be fun. We see that our paperclip conducts electricity really, really well. Look how fast we're going through our current. Our current's really, really big because we put a paperclip in there rather than a light bulb. Kind of interesting. All right, let's put back our light bulb and try something else. So what was our next thing? So let's put 2 batteries in and see how it changes our voltage and our amps, our current, I should say. So just for fun, we can put batteries together like this in our circuits and measure. Oh, I forgot the lights. I forgot the light. We still need the light bulb. So what happens now is we have twice as much voltage. Our voltage went from 9 to 18, and our current went from 0.9 to 1.8. So both of our voltage and our current got twice as big by putting another battery in, which is interesting. And I think even our lines on our light bulb got a lot bigger too. Let's look at how it looks in our diagram though. So I'm going to take these out just for simplicity. We don't need to see all this. I want to get this out of the way. I'm going to get rid of our electrons too. So I just want to look at our diagram here. That's the word I was looking for, sorry. So we have 1 battery, 2 batteries, we're going to go to a light, and then the rest of this is just, oh, this is our switch, and then the rest is wires. So we have a switch, battery, battery, and a light. So those are some of our examples. Let's not get into resistors just quite yet. So this is a fun interactive questions that I'm going to leave for you guys to do in our Google Classroom, because I want to get to drawing some of these examples together. So let's look at this. We have a light, a switch, and a battery. So let's try to draw that together. I don't have it drawn here. I'm going to use our little construction fun thing here. So we have first, let's put the battery in. I think that's always the easiest place to start. We can put a battery. The next thing we're going to put is a light bulb, and I'm going to switch this to our diagram. So we're going to draw our battery. We're going to put our light bulb next, which looks like this. We're going to then put a switch and connect them. So this is what our diagram would look like. We wouldn't have these big circles. I would just draw this as a little bit nicer if it were up to me. I'm going to actually make it look a little bit nicer. It's just so that I can show you guys what it would look like. Why is this not letting me change it? Maybe we cut this. That's a little bit better. So I would draw this more of like a square. So we have our battery going to our light and then a switch. So we really need 3 symbols if we wanted to do this one. What about our next one? This one we have a battery, a light, a light, a light, and then go back to our battery. So let's draw this one together. So we have 1 battery. Oh, let me do this. Go back here. We have 1 battery. So we're going to draw a symbol that looks like this. We have 3 lights in a row. Let's see how this works. Light bulb, light bulb, light bulb. I don't like how that last one went in there. There we go. So we have 3 light bulbs, 1, 2, 3, and then we're going to go all the way back to our battery. So we're going to go up and around, and I'm going to use a couple wires just to make it easy. So it's a lot easier if we're drawing it on paper than on this little diagram here, but the idea is all the same. So we have a battery, goes to 1 light, 2 light, 3 lights, and then goes back to our battery. Our last one real quick, I'm going to show you guys just the answer because I'm running a little bit short on time to record this video. So I just quickly drew this one out. We have a battery with a loop to a light and then another loop to a separate light. So we have our battery, we're going to go and loop to this light, and then coming off that same light we loop to the second one. So I hope that makes sense. We'll be learning a lot more about circuits as we go.